This is First Coast Math Clinic with video number 2, geometric sequences, for Unit 6, patterns and sequences with a pre-algebra focus. So the goal in this video is to identify patterns to find missing values for geometric sequences. So in the previous video, we talked about arithmetic sequences. We're going to compare geometric sequences to arithmetic sequences, and we'll review sequences versus patterns. So let's get into this information. Just a quick review of patterns versus sequences. Pattern, we said, is the rule for creating the sequence. So pattern is how we get the sequence. Sequences are the actual values in the set. So sequences are the actual numbers. The pattern is the actual rule. So like sequences are actual values. Pattern is the rule for getting those values. Okay. And in the previous video, we talked about arithmetic sequences. In this video, we're going to talk about geometric sequences. Well, what's the difference? So arithmetic sequences are sets of values formed by adding or subtracting a constant value. So we're adding or subtracting a constant value. In geometric sequences, there are sets of values formed by multiplying a constant value. So arithmetic, we're adding or subtracting. Geometric, we're multiplying. So what's the difference? Well, let's look at a couple sequences. So for our arithmetic sequence, easy sequence, 2, 4, 6, 8, 10, 12, 14. Well, what's our pattern here? Pattern is plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. So that's our pattern. Well, what would a geometric sequence look like? So something like this, all right? 2, 4, 8, 16, 32, 64, 128. Well, what's our pattern here? Well, instead of adding 2, we're multiplying times 2 times 2. So every next value is the product of 2 and the previous value. So our pattern here is times 2. So in this video, we're going to look at geometric sequences where we're multiplying our specific value in our pattern. So let's get into some examples. So for example 1, our pattern is 2, 6, 18. So first thing I'm going to do is figure out, well, what's our pattern? Because once we figure out our pattern, we could figure out our missing values in our sequence. So the easiest way to do this is I like to number our values, number the terms. So let's give you our 0th, our first, and our second term. Now we know that we're multiplying our previous value times our pattern to get our next value. So the easiest way to figure out a pattern is basically work backwards. So maybe divide that first term by the 0th term. So if we divide like 6 by 2, we'll get 3, and that's our pattern, right? So 2 times 3 is 6, 6 times 3 is 18, and then we'll just continue that pattern. Times 3 is 54, times 3 is 162, times 3 is 486. And we could figure that out again by taking any set of values, our value, and dividing it by the previous value. So we're taking, in this case, like our second term and dividing it by our first term. All right. So for number 2, we'll do the same thing. We've got our 0th, first, second term. So to find our pattern, I'm going to divide my first term by my 0th. So 14 divided by -7 gives me -2. So my pattern here is -2. So we're multiplying by -2. So times -2 times -2 times -2. And the clue that we have a negative value is we go, if we look at the pattern, we have negative, positive, negative. So we know our signs have to change here. So we should have 56 here, -112 times -2, and then times -2 again and get 224. For number 3, our pattern, so this is our 0th, first, and second. So I'm going to divide our first term, the 4, by our 0th, which is 8. And well, this doesn't divide out quite as nicely, but we get 4 over 8, which reduces to 1/2. So our pattern here is we're multiplying by 1/2. So times 1/2 times 1/2. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. So remember 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So that's our 1/4. Okay. Let's do a couple more examples. So number 4, we've got 81, 27, and 9. So again, 0th term, first term, second term. Let's divide our first term by our 0th. So I'll do 27 over 81. Well, I could factor this out into, let's break this up into maybe 27 times 1, and 81 is 27 times 3. All right, so we're factoring that out. 27 divided by 27 is 1 over 1. So our pattern here is just 1 over 3. So we just reduced 27 over 81, right? Or if you don't want to use 27 or 81, you could have used these two values, 9 and 27. If we take 9 over 27, well, 9 over 27 reduces to 1/3, and that's our pattern, right? So 81 times 1/3, a third of 81 is 27. A third of 27 is 9. A third of 9 is 3. 1/3 of 3 is 1. And 1/3 of 1 is 1/3. All right, number 5. So our pattern, again, we've got our 0th, first, and second term. So I'm going to divide my first term, -12, by my 0th, 3. So our pattern is going to be -4. So we're multiplying 3 times -4. And then 12 times -4 to get 48. So again, notice our signs are changing. Positive, negative, positive. So the next one should be negative. 48 times -4 is going to give us -192. Times -4 is going to give us 768. And then times -4 is going to give us a negative, and it should be 3072. And last one, so 0, first, second. Let's divide our first term by our 0th, so 16 over 64. Okay, so 16 over 64. We could break this down into 16 times 1. And 64 is going to be 16 times 4. So I'm just factoring out my 16 and 64. 16 divided by 16 is 1 and 1. So I'm left with just 1 over 4. So that's my pattern. So I'm multiplying 64 times 1/4, and I get 16. 16 times 1/4 is 4. 4 times 1/4 is 1. 1 times 1/4 is 1/4. And we write that a little neater. And 1/4 times 1/4 is 1/16. So again, remember how we're going to multiply that. 1/4 times 1/4. Multiply straight across. 1 times 1 is 1. 4 times 4 is 16. Okay. All right, so these are 6 examples on finding the pattern and using that pattern to complete our geometric sequences. If you like this video, leave a like, comment, and subscribe. If you want to see any additional videos on some different topics, leave those in the comments. Again, I hope you guys are liking these videos. If you're liking them, leave a like, comment, and subscribe. First Coast Math Clinic.